probability type of plot, and I'm not sure that I'm understanding that lingo and if it's if it's correct or not, or if it just means something simple.
A quantile plot, sometimes called a QQ plot, is you can do it right here with this menu set in SAS, right? So you go through task, statistics, distribution analysis, and then go from there. So tasks, statistics, distribution analysis. Double click on distribution analysis, and then of course load your data set. Now you said this was for 329, so we've got to load 329. Hit the little running man. Okay, and then go back to our distribution analysis. Grab import one because that's our running man. We got to pick our analysis variable, which there's only one, treatment time. So we're going to put that in there. And then let's see, what else do we have to do? Put in your data set, roles, analysis variable equals treatment time, options. Checking for normality, right? We've got to use this and then do the quantile plot to get what we want. Because if we just ran this, it's not going to give us what we want. Like, so for instance, if I just run it right now, we get a histogram. You're like, okay, well, that's not what I wanted. All right, so if you go to options, down here, checking for normality, because that's what a quantile plot does, is it tells you how close your data set is to being normal. It's a way of checking for normality. And we all know normal means the nice little pretty bell curve, right? So we're checking to see how close our data fits that pretty little bell curve shape. So you can just tick off all of these to get as much information as you want, right? Normal probability plot, blah, blah, blah. But really all you need is this third one, the normal quantile plot. Click on that and then click on add inset statistics and then tell it what kind of inset statistics you want, and you want a goodness of fit test. And then if you want, you can also click on fitting distributions and you can play around with these, but we don't need to do any of that in this class. I do like what is kind of fun is with the histogram, you can add the normal curve to it to see how it fits, right? You could also turn the histogram off because you don't really need it. All we need is the quantile plot. But I think if we do all of this, you'll kind of see what it all tells you. So here's your histogram, right? And then here's your normal graph. And you can see how the data works that way. And then if we scroll down, here's our quantile plot. And then here are our values here. And you're going, okay, so what the hell does this tell me? Okay, so the more normal your data gets, the more the dots will line up on this straight line. So you basically want your dots to be all around the straight line with no discernible pattern. So if they were really close to the line, but they kind of went up, down, up, down, up, down, up, down, up, down, up, down, then you would know there was something hinky going on with your data. But as long as it's relatively random, right, there's no real discernible pattern, and the dots for the most part are really close to the line, and then they can trail off in the tails because, you know, the tails are kind of where the outliers are anyways, then you can say this is getting fairly normal. And then the normal test up here is basically testing for whether or not your stuff is normal. Now, the test statistic, that one's hard to explain, but the p-value is really easy. If you guys have done anything with any kind of hypothesis testing, or if you've ever heard of p-values, it's a way of asking what is the probability that the test that I just ran is wrong or false, right? And so basically the test that we ran for normal is telling us that there's only a 3.8% chance that this data does not come from a population that is normally distributed. So it's pretty damn normal, right? I mean, if the data was super normal, then that would get even smaller, it'd be closer to 0%. But so you're looking for a small p-value, and that tells you that your data is normal. So this tells me that this data is pretty darn normal, which you can see from here, right? I mean, it's fitting this normal curve pretty well. The only problem is you've kind of got a snub tail here and a longer tail there, right? So it's slightly skewed. And in fact, if we ran the statistics on it, we would see a slight skewness to it. but it's close enough that we're assuming it comes from a population that is normal. Because remember, even if the population is normal, it doesn't necessarily mean that every sample from it will be normal, but it should be normal-ish. And that's what we're getting here.
Okay. So it truly is the QQ plot, which really just threw me off because, I mean, it's just a measure that I've hardly seen used before. So I just didn't think it fit with where we are basically in this chapter of the class. But if that's all it is, then that's what I'll do.
Yeah. It all it does is taking your data values and it's calculating the quantiles of it. And then it's kind of graphing the data value versus its quantile. And then that's a way of determining if it's normal or not, if it lines up kind of on a straight line. And you can see that it kind of does. Okay, what else?
3.69b. I'm a little confused on.
369b. Oh, where they want you to find the correlation. Okay. 369. This. The easiest way to get correlation is to simply go to statistics and just do correlation analysis. It won't give you the scatter plot. The scatter plot is much easier to get by just running the scatter plot here up in the graphing thing. So as I said in previous meetings, there are ways to get it to give you the scatter plot and the correlation all together, but that menu driven operation is a little confusing to work through. It's much simpler to just run two operations. So first you would run the scatter plot menu option on your data, and it would give you the scatter plot. And then you come down here and just do correlation analysis. Pick your data set, right? Which for me is now import 2. And then you put in your analysis variables, and you can literally just put in both variables in one. You don't have to put correlate with. If you put them all here, it's just going to give you a table and show you how they correlate to everything else. So if I run this, there's my table, right? I'll make it a little bigger so we can all, ooh, a little too big. Back up. There we go. So we can see that AIDS correlates to AIDS with a 1. Well, no, duh, right? Any variable is going to correlate to itself with a correlation of 1 because all the numbers match up perfectly. Just like syphilis correlates with syphilis to a 1. What you're looking for is the ones that are off of the diagonal. And this tells me that syphilis corresponds to AIDS at 88%. And then this one tells me that AIDS has a correlation with syphilis of 88%. And again, you go, well, no, duh, right? The correlation is always going to be the same if I say, hell, this correlates to that the same way as that correlates to this. Well, yeah, of course, because you're just comparing the same two things. Basically what it helps you know is that when you're talking about correlation, it doesn't matter which variable goes first. You're still going to get the same correlation. And so that's the easiest way to get the answer for 69B is to just run that simple correlation analysis program, function, whatever you want to call it in SAS. Okay, what else?
380B also, if you have time. I didn't want to monopolize.
Well, it's the same process, just use the different data set or the different variables, sorry. Well, yeah, different data set as well, because you're doing 380. So do the exact same thing, just load your data, put in the two variables, which in this case is airflow and price, and you'll get this exact same table, only you'll get, airflow price, and then you'll just look for the numbers for those two. It's a much weaker correlation, by the way, and that should make sense, right? I mean,
yeah, that was just stupid on my part.
Okay. What else? Anybody?
I'm good.
Awesome. I like to hear it, Mary.
Well, I mean, I got a little work to do tonight and first thing in the morning, but I'm okay. And we had a little meet last night and Lonnie helped us a lot. So
yeah, that was
fun.
I saw you guys I saw that go up in the dialogue, and I saw people chiming in, and I was so mad at myself for not suggesting that from the very beginning. I should have suggested that all along, that since most of you have that time available, I should have just left the Zoom meeting available and you guys could have joined it without me. And, but I'm glad you guys took the initiative and created it, because that was very, very smart. And I'm sure it was very helpful for everybody.
Oh, yes.
Okay. So,
Great. One question.
Yeah, Michael, go ahead.
Yeah, in the on the mini project, there's I guess these aren't numbered, but it's where you ask for the 5-number summary, mean, standard deviation.
Yes.
So I've got a table of all of it. Do you care what order they're listed in, or just the fact that they're there?
I don't. If you ran it in SAS through the menu system and didn't do any kind of coding, then it's not going to put them in order. It's not going to put them in the proper order. It's going to put them in the order that SAS wants to put them in. So for instance, I'm just going to use this data set, even though it's the wrong data set. And if I run summary statistics on it, of course, to get the 5-number summary, they wanted the 5-number summary plus mean and standard deviation. So here's mean, here's standard deviation. Then you want min, max, median. And then all you want is lower and upper quartile. And those would be your 5-number summaries plus the mean and standard deviation. And then, of course, it puts it in the order basically in which they show up here in the menus, right? So it goes min, standard deviation, or sorry, mean, standard deviation, then min, max, then your median, then your lower quartile, your upper quartile, which is fine. All the information is there. But if you were going to put this in your dissertation, so you were going to create a table and put it in a dissertation, or if you're going to put it in an article or whatever, you should really put it in the proper order. And the 5-number summary, the numbers go in their obvious order, right? It goes minimum, then it goes lower quartile, then it goes median, then it goes upper quartile, then it goes maximum. Basically the 5 numbers that create the box and whisker plot in the order in which you see it. Because if you graph, the whisker plot on a number line, obviously the minimum is the number farthest to the left, and then the next number up is going to be the first quartile, because that's your 25%, then your medium at 50%, then your upper quartile at 75, and then finally your maximum. So that would be your 5-number summary in that order. And then you could put mean and standard deviation either before it or after it. There's really no rule about that, but that would be technically the most accurate way to display those. As far as the project is concerned, I'm totally fine with you just snipping this table and putting this table, right in your paper and going, it's good enough. Now, if you wanted, to get SAS to do it the right way, you would have to click on code, click on edit, which all it does is it copies everything you had, but it now makes it editable, right? And all you have to do is relist these things in their proper order. So instead of the order they're in, right, min, max, and all that crap. So you go min, and then you go Q1, median, Q3, and max, right? And then I'll just get rid of the extras. So here's Q1, here's Q3. Get rid of my extra median. And so now you can see right here is my 5-number summary in the proper order: min, Q1, median, Q3, max, and then I just leave mean and standard deviation first. That's fine. And if I run it, I'll get, oh, what did I screw up? What's wrong? 180 to 122 min. Weird. Why is that wrong? Oh, all right, let's try that again. There we go. I don't know why I didn't like it, but okay. Now you can see that everything is in the proper order: mean, standard deviation, and then you got min, lower quartile, median, upper quartile, max. Again, not necessary, just showing you something if you wanted to play around with it.
Thank you very much.
Of course. What else, kiddos?
That's how I felt all this week.
Yes, that's how I felt when my headset wouldn't work.
Any words of wisdom on week 4?
Well, probability is the area of statistics where students historically struggle the most.
Ugh.
So my suggestion would be jump on my instructional videos, and then of course the meet session videos, session 2 more than session 1, because that's where I answer questions. Watch those as early as possible to help you from making some of the most common mistakes. First and foremost is, even if you understand how probability works, some of the questions in the homework are not written extremely clearly where you could misinterpret what they're actually asking. And what I mean is, there are a couple questions that are actually giving you some information. So they're actually asking for conditional probability. They're telling you that something is given something else. But if you don't read it that way, you would compute it completely differently. And let me give you an example. It's not like the homework, but let's say you have a bunch of statistics, a bunch of data that you gathered on people, right? Males and females, and different voting preferences, right? So everybody told you their gender, they told you their age, and they told you their voter affiliation, right? They're Republican, Democrat, Independent, non-affiliated, whatever, that kind of thing. Then you could ask a simple question. What's the probability that a male is Republican? Now, some people might interpret that as, okay, what's the probability that if I picked one person at random, they would be both male and a Republican? And then you would go out and you would count up in your data set how many Republican males you have, and then that's your good, because probability is always good over total. And then you would just divide that by the total size of your sample set. So you go out and you go, okay, there were 27 Republican males out of a sample of 43. So 27 over 43, and it's a little bit over 50%. Well, that might not be what that question was actually asking. And in fact, that question probably wasn't asking that, because if you wanted to know that, you probably would have stated it differently, and you would have said, if you pick somebody at random, what's the probability that they are both a male and Republican, right? You usually use the word "and" in there to denote you're looking for an intersection of two things, right? You're looking for the intersection of males and Republicans. When they state something as, what's the probability that what is the probability that a male is Republican? Because they told you that they are a male and they want to know if they are Republican, then the characteristic of being a male is given. That is you're considering that as a given condition. So now you're doing conditional probability. So instead of looking at your entire set of data, you're only going to be concerned with the males. So basically what you're doing is, if you envision a big auditorium, you go, okay, men over on that side, women over on that side. And now you're only going to look at the group of men. And let's say within that group of men, so now your group of men there's, let's say 30 total men. Well, that becomes your new total. You don't care about all the women because that wasn't part of the question. The question was, what's the probability that a male is Republican? So within those 30 males, you count up how many of them are Republicans. You go, okay, I've got 20 out of 30, right? So I've got 20 of the 30 were Republicans. So now your good is 20, but your total is just the 30 total males instead of the entire set of people. And that answer becomes 20 out of 30, or 2/3, or basically 66%. That's how conditional probability works, is instead of looking at the group as a whole, you look at the subset of objects that are classified with the given condition. And if the given condition was males, you're only looking at the males. If they had said, what is the probability that an independent voter is female? Well, then you would take all the independent voters, stick them in one section of the auditorium, and that becomes your new total. And amongst those, you would count up how many females there are, and that becomes your new good. and it would be that good over that total. And that's how conditional probability works. And that's one of the easiest things to get wrong in the homework, because the wording of the question just doesn't seem to be obvious that they are asking for a conditional probability. But I can tell you that if you concentrate on learning formulas when it comes to doing probability, you will rip your hair out, because they are confusing and tedious, and it's hard to figure out which formula to use when. You only ever need to worry about formulas for doing probability if you end up going into a far more advanced probability and statistics course, which I doubt any of you will ever take. So it's not worth your time to try and learn how to use all the formulas to calculate probabilities. Instead, you want to use my patented, copyright pending dash technique, which is a beautifully easy, elegant solution to figuring out probabilities, where you simply just put down dashes and fill them in with good over total, whatever the question is. It's very easy to compute, and all you're doing is you're counting. You're just simply counting how many good there are and how many total there are. And just based on the question, you just have to be sure that you don't miscount anything or count things twice. So really, it all comes down to, can you count? And it's a lot easier. So definitely make sure you watch my videos on the dash technique and understand how that works. Definitely watch my videos on, just basic probability, because I'll talk about good over total and try and, drive that home. And then just, go straight to the week 4 session 2 videos and, watch me go through a lot of the homework questions with past students, and you'll see how it all fits together, how the dash technique and the good over total works with those particular questions, and it'll become very easy. In addition to that, week 4, is when you want to start thinking about the final project, just because there is probability in the final project. So even though the final project isn't due until the end of week 6, it would be a good idea to open it up, print it out, whatever you are going to do with it, and just have it handy, read through it and understand, oh, there's some questions in here that are asking about probability. So as I'm learning this probability stuff, keep that in mind, see if I can maybe apply it to the final project questions, and kind of, so when it's fresh in your mind, you can do them, and then you can set that aside, and then when we learn something else that applies to it, you can then apply it to it and just kind of work on it piece by piece as you're working through the other stuff. And that would be my suggestion for week 4. And then, of course, I think week 4 is when your critique is due, is it not?
Yes.
When's the critique due?
Yeah, week 4.
That's what I thought. Yeah. So the other thing you have to keep in mind is that your article critique is due by the end of the week. So the only thing you have to do next week is the homework for week 4 and the critique. But my suggestion would be also get started on the final project. Just doing any questions that have to do with basic probability. And there's a section in the final project that's all about basic probability that you could hammer out really quickly in Excel. Once you understand how to do stuff in week 4. Okay, anything else?
Dr. McClure, this is Tiffany.
Yes, Tiffany.
I have a question that's, well, it's not specifically about the homework, but on when you upload your, like, let's say the Zoom from Monday, you don't have it on that little thing yet. So I had issues with my computer because there was a firewall. So I tried to go to the link that you actually give us after the meet is up, but I couldn't connect because of, so the only way I can actually connect is when you actually put it on that Word document. Yeah, you know how you have week 1, week 2, week 3.
Yeah. I uploaded it a couple hours ago. It should be.
Yeah, I saw that today, but I was on the plane and I was on there for like 5 hours and I wanted to, I couldn't get to it, and I was like trying to fix this firewall that wouldn't let me connect it from the actual link you sent us, like, like shortly after Monday's,
Yeah.
So I was like asking in the future, will you like always up this on the Word document later?
Well, the only reason why it went up that way is because I was on the road. And
Okay.
So
Okay.
yeah, everything should go on the Word document much quicker from here on out.
Okay. And then I tried to go onto your actual YouTube and I couldn't find it there either. So I was like, how do I get?
Yeah, you can't find it on YouTube because they're all unlisted. You have to have
Got it.
the
Okay.
direct link to get to it.
Yeah. Okay. That's what I figured. But I was like, I was driving myself crazy trying to figure out that firewall, and I still can't get it fixed. I'm not a computer person.
I feel your pain.
Thank you.
Yep. Anybody else? All right. Well, I am going to go throw my laptop in the sound, and I will see you guys on Monday.
Thank you.
Thank you.
Thank
Good night.